Hello students, today we will learn about the first chapter of physics ICSE, that is force. So let's start with the definition. What is force? Force is the cause due to which a body changes its state of rest or motion with respect to time. Now, when you give force to a body, a stationary body, it will move. And when you apply force to a body which is already in a motion, it will slow down or it will increase its speed. Something will happen. So, the force is the reason due to which a body changes its state of rest or motion with respect to time. Now, depending on how you apply force and what kind of body it is, the type of motion changes. For example, let's take a rigid body. A rigid body. Now, what is a rigid body? A body which is very hard, very firm. Okay, when you apply force on a rigid body, the motion that it will do is a translational motion or translatory motion. Or in simple terms, we can say linear motion. A body will move in a straight line, that is motion in a straight line. Okay, another type of motion can happen, that is a curvilinear motion. Means the body is moving in a curve, or a rotational motion. Okay, so the two kind of motions that can happen when you apply on a rigid body. If you apply the force on a rigid body, the body can have two type of motions. One is translational or linear motion, moving in a straight line, and another one is a curvilinear motion, moving along a curve, or a rotational motion, moving in a circular pattern. One more thing, if the body is not rigid, if the body is a non-rigid body, if a body is a non-rigid body, when the body is not rigid, that means it's firm, it's strong, it's squishy, you can say. So when you apply force on a non-rigid body like a rubber, let's take a rubber. Which is a non-rigid body, what can happen? What kind of motions can happen? Well, it will have linear motion, and also it can have curvilinear motion, and something else, and the shape, size and structure will change. So when you apply a force to a non-rigid body that's not so firm, it will have the two kind of motions, basic motions, whereas the shape, size and structure will also change. But this point is not applicable for a rigid body, because rigid bodies are firm. You can't change its shape, size or structure by applying a certain amount of force. You need a huge amount of force, a considerable amount of force to change its size or structure. Now, Upon this thing, upon this topic, there comes two more things. One is pivoted body. What is a pivoted body? A pivoted body looks something like this. A body whose center position is fixed, or you can keep it like this also, a body whose one end is fixed. These are known as pivots. The fixed points are known as pivots. These are known as pivots. Now, when you apply force on a pivoted body, the only motion that it can do is a rotational motion. Because now, since it is fixed at a point, it cannot move in a straight line, it cannot move in a curved line. So, translatory motion or linear motion or curvilinear motions are out of questions. So, the only motion that a pivoted body can do is a rotational motion. In only pivoted body can only do rotational motions. Pivoted bodies can only do rotational motion. It's a very simple example. Let's say if I'm applying force from the bottom part, this body will move in an anti-clockwise manner like this. Like this. It will move in an anti-clockwise manner. Same goes for the upper diagram also. If we apply force over here, it will move in a clockwise manner. Clockwise and anti-clockwise manner. So these are all types of rotational motions: anti-clockwise rotational motion and clockwise rotational motion. So let's revise the topic once. If the body is pivoted, it cannot do linear motions. The only thing it can do only rotational motions. Only rotational motions. It cannot do linear motions. No linear motions. It cannot do any linear motion because it is fixed at a point. How will it go again in front? So when you apply force to a pivoted body, it can have two kinds of rotational motions. Number one, anti-clockwise rotational motion, and number two, it's clockwise rotational motion. So this is the basis of the first force chapter. So I'll revise it once more for you people. What is force? Force is the cause due to which a body changes its state of rest or state of motion with respect to time. Two types of bodies are mainly found in physics. One is a rigid body and one is a non-rigid body. If we apply force on a rigid body, it can do three types of. If you apply force on a rigid body, it can do three types of motion, primarily translational motion, linear motion, curvilinear or rotational motions. So the translator or linear are kind of same. So you can say three kind of motions are applicable when the body is a rigid body. Whereas when the body is a non-rigid body, in that case also the body will have some amount of translator as well as curvilinear motion, and addition to that, its shape, size and structure will also change. Since it's not rigid, it's kind of flexible. Now, if the body is pivoted body, now many may question this: what will happen if the pivoted body is non-rigid? What will happen if the pivoted body is non-rigid? Now, if you ask in the syllabus we are all considering about rigid pivoted bodies. So let's not go into those topics. So for rigid pivoted bodies, the bodies will have only rotational motions, no translatory motions. There are two kinds of rotational motions that is done in a pivoted body: anti-clockwise or clockwise. Now let's move to the next topic. that is linear or translatory motion. As discussed, let's say I apply force in this direction. The body will move in this direction, motion, right? So that is a simple linear or translational motion, motion in a straight line. Motion in a straight line, simple thing. What is rotational motion? Now let's assume the wheel of a car, or let's assume the steering of a car. The steering of a car is fixed at the middle, that is the pivot point. This red point in between is your pivot point, is your pivot. Now when you apply force on this side, obviously the wheel will move in the, or the steering will move in the clockwise manner, in a clockwise direction. And when you change the point of application of force, then the wheel will move in a anti-clockwise manner. So you can see one thing, that by changing the point of application of force, you can change the rotational motions. Okay, so if you apply on the left hand side of the steering, it is going to go in a clockwise manner. If you are applying force on the right hand side of the steering, it is going to move in a anti-clockwise manner. So the two types of rotational motions are over here. Now let's move to our next topic, that is moment of force or turning effect of force, or specially known as torque. Now, till now we have learned about the basic concepts of forces, the rigid body, pivoted body, non-pivoted body, the type of motions and everything. Now these are the applications of those kind of forces on pivoted bodies. Now this is a wrench. We all use this at home to tighten or loosen a screw. Now let's assume we want to tighten a nut using this wrench. Now to tighten a nut, if you observe, to tighten anything, you need to do a motion of clockwise direction. Whereas if you want to loosen anything, loose a nut, you have to do a motion of anti-clockwise. So let's assume that I want to make this nut loose. So what I will do is, I will try to give the force in the upward direction. And the distance of the force from the nut, let's assume it to be D. Torque or MOF, torque or MOF, MOF is the short form moment of force, has a formula F into D. What is D? Perpendicular D. Means the direction or the distance from the pivot or the nut to the force in a perpendicular manner. That is the formula of torque, force into perpendicular distance. Now, you can clearly see that the farther the distance, the lesser will be the force required, because the MOF or the torque of a nut is fixed. So, farther the distance, more the distance, less will be the force required, and vice versa, obviously. Clear? So more the distance of the instrument or the tool, less will be the force required to open the nut. Same goes for the door. We all have opened a door using the door handle. The end of the door, this is the hinge part. This is known as the hinge or the pivot part, along which the door opens and closes. Now we have all seen that the distance of the hinge from the doorknob is kept the farthest, so that by applying a minimum amount of force, you can open the door easily. It goes on this concept: more the distance, less will be the force required. So for here also, torque, now torque has a symbol like this, is F into D. F into D, that is the torque. Now let's discuss a few things on this topic, that torque, that is tau, this formula is known as tau, or moment of force, has a formula of F into D, or perpendicular distance, you can say tau. Conditions for maximum torque or maximum moment of force. Three conditions. Number one, F should be maximum. Number two, distance should be maximum. There are two formats for which the torque can be maximum. And again, the conditions for zero torque means when there will be no MOF. Number one, force applied 0. You have applied no force only, then how will the nut happen? Number two, distance, perpendicular distance 0, means you are applying the force but not at a farther point on the nut, or you are applying the force on the hinge of the door. You can't open a door by applying force on the hinge, because that is the point where through which the door moves. So if you apply the force, if the distance is 0, means you are applying force, you have force, but your distance is 0. From the pivot point, you are not moving forward, you are applying force on the pivot only. So that will be a 0 distance. And 0 distance, if you apply F into 0, it's 0. And number 3, a special case, when the force passes directly through the axis of rotation or the pivot point. Okay, so this is a new case when the force directly passes through the axis of rotation or the pivot point. These two concepts are very important. They are quite often asked in your school exams. Do write them down. Now let's move to the next topic. This is clockwise and anti-clockwise moment. We have already discussed about the clockwise rotational motion, anti-clockwise rotational motion. Now here I have taken two meter scale. Meter scale means they have been marked from 0 to 100. From 0 to 100. Now let us put a force at a point of 10. So let me write it down. So at the 10 centimeter mark, you are applying a force of, let's say, 5 Newton. This is the fulcrum or the pivot point. Okay, the fulcrum or the pivot point, that's 10 centimeter. This is 50 centimeter. So the distance between this is 40 centimeter and the force applied is 5 Newton. So what will be the torque or MOF? F into perpendicular D, that is 5 into 40, that is 200. But make sure you do the necessary conversions. The necessary conversions are 200, for 5 it was Newton, nothing required, but for centimeter you have to divide it by 100 to get into meter. That's 2 Newton meter is the torque. Now, when you apply force on this left hand side, this body will move in a clockwise manner. So this clockwise under physics is said that when there is clockwise, it is assumed to be as negative. Clockwise moment of force is assumed to be as negative. Okay, clockwise moment of force is assumed to be as negative in physics. Now, if we move a step forward, if we repeat the same thing, but this case, in this time, we are applying force at the 90 centimeter mark. Here is the 90 centimeter mark, the fulcrum is at 50. The distance from the fulcrum to the point of force is again 40 centimeter. Let the force be 5 Newton. Now if you apply the force, you can see that the body will move in a anti-clockwise manner. Anti-clockwise manner. And the anti-clockwise moment of force is assumed to be positive. So in this case, the moment of force will be F into perpendicular D, that's 5 into 40 by 100, that's 2 Newton meter. Final answer, anti-clockwise. And here would have been 2 Newton meter clockwise. That's the final answer that you have to write to get full marks. Now, one important topic that I should bring to your notice, that the unit of torque is Newton meter. There is another physical quantity whose unit is Newton meter, or rather say quite similar to Newton meter, that is work done or energy. Energy is also force into distance or force into displacement. Force is Newton and displacement is meter. So work done also comes to be as Newton meter. But why we prefer work done's unit as joule and not Newton meter? The reason is work done is a scalar quantity, whereas torque is a vector quantity. Torque is a vector quantity. Okay, the reason it is called vector, because let me give you a basic physical example. Let's say you are trying to open the cap of a bottle. Just take a bottle on your hand and try to open the cap. Your motion will be anti-clockwise, but the cap will come in the top direction. So your motion is like this in a horizontal motion, but the cap's motion is a vertical motion. When you try to tighten the cap, again you do a clockwise manner, but the cap moves down. So make sure you see this properly, that your motion is anti-clockwise or clockwise, but the cap's motion is vertically up and down. When these two kind of motions occur, then it is called a torque, and hence it is a vector quantity, because the motion is in a perpendicular to the force applied. That's why it is known as a, I would rather say the displacement is perpendicular to the force applied. That's hence it is a vector quantity. Now let's move to the next part. It is a couple. What is a couple? Now again I have taken a 100 centimeter scale, is marked from 0 to 100. In this case, I will apply two similar forces on two ends of the ruler, equal distance from the fulcrum. So let's assume I am applying at the 10 centimeter mark and at the 90 centimeter mark, but this time I am applying one force from bottom of 5 Newton, F equals to 5 Newton, and a similar force from top, F equals to 5 Newton. So two similar forces acting on the same body but at two different points. Okay, and they are parallel to each other. This kind of system is called a couple. Two similar force, same magnitude, opposite direction on the same body. This is known as a couple. Okay. Now, if you are asked to find the torque or the moment of force of a couple, you will always see that the couple has a single direction of rotation. In this case, both the force is making the couple move in a clockwise manner. Both the force is making the couple move in a clockwise manner. Okay. Now, what is the net torque? To find the net torque or the net moment of force, just to do one thing, use the force value into the distance, the total distance from one force to another force. The total distance, use the total distance, that is 10 to 90, that's 80 centimeter. I will write here total distance between two points of force. So according to this formula, it's going to be 5 into 80 by 100, that's 4 Newton meter, and clockwise. Make sure you write this direction in exam to get the full marks. So that is a couple. When two similar forces of same magnitude but acting on the same body but in opposite direction at equal distance from the fulcrum, and the body is moving in a single direction, they are known as, the system is known as a couple. Clear? Okay. So, see, 10 Newton and 15 Newton. So that's all for today in this class. We will continue with the next topic in our next video. Thank you everyone. Please like, share and subscribe.